Hello everybody. Today we are going to discuss how to find a derivative of a function using the table of differentiation. Here we have some functions with their derivatives, and we will discuss the other functions with their derivatives in the upcoming lectures. For example, if you have a function x to the power n, so its derivative is n x to the power n minus 1. The derivative of a constant c is 0. The derivative of a to the power x, where a is a constant, equals a power x ln a, and so on. So we have example number 1. You have to put this table inside your mind, and you have to remember it well to solve the following problems. Problem number 1, if y equals x to the power 4 plus 2x to the power 3 minus 3x minus 1, then find dy dx, which is called the first derivative of the function y. Here we have the needed rules in this problem. Here dy dx, derivative of y with respect to x, or let me say y prime equals derivative of this function x to the power 4 using this rule here, x to the power n, its derivative is n x to the power n minus 1. You have to put this power down. So put the power down here and subtract 1 from the power, so you have 4x to the power 3. Next, 2x to the power 3, you can use the same rule. Put the power down, so you have 2 times the power 3, which is 6. Put the power down, put 3 down, so 2 times 3 equals 6, and subtract 1 from the power, so you have x squared, minus derivative of 3x, which is 3, and derivative of the constant is 0. Here derivative of negative 3x is negative 3, because here the power is 1. If you put the power down, 1 times negative 3 is negative 3. Subtract 1 from the power, so you have x power 0. You don't have to write x power 0 because x power 0 equals 1. So the derivative of negative 3x here is negative 3. Derivative of the constant, derivative any constant according to the table of derivatives equal 0. Another example. Here we have y equals root x plus cubic root x minus 1 over x squared minus 1 over root x. Then find y prime, which is dy dx, the derivative of y with respect to x. Here we have the needed rules in this problem. You have to rewrite this problem again in a simple way, in a simple method. You can write y equals root x plus cubic root x, which is x to the power 1/3 minus, here you can raise x squared up to be negative x power negative 2, minus you can raise root x up to be x to the power negative half. Now you have to find the derivative. Y prime equals derivative of root x according to this rule. Root x, its derivative is 1 over 2 root x. So you can write here root x is 1 over 2 root x. Plus derivative of x to the power 3rd. Put the power down here and subtract 1 from the power, so you have x to the power negative 2 over 3. Here put the power down, so you have minus negative 2, which is plus 2. Subtract 1 from the power, so you have x to the power negative 3. Here put the power down, minus negative half, x to the power, subtract 1 from the power, so you have here x to the power negative 3 over 2. Another example. Find the derivative of y, find y prime here, where y equals 3e power x plus sine x minus cosine x plus tan x. If you have a look here, these are the needed rules to solve this problem. Here, e to the power x, its derivative is e to the power x according to this rule. E power x, its derivative is e power x. So you can write 3, and the derivative of e power x is e power x. Derivative of sine x is cosine x according to this rule, and the derivative of the cosine x is negative sine x according to this rule, so we have minus negative sine x, which is plus sine x. Tan x, according to the rule here, tan x, its derivative is sec squared x. So this is the derivative of the given function. Here we have y equals ln x plus sec x plus 2 to the power x. Find dy dx. According to this table, y prime, or we can say dy dx, derivative of ln x is 1 over x according to the rule here, and derivative of sec x is sec x tan x. 2 to the power x, its derivative according to this rule here is 2 power x ln 2.